Breaking news. Tesla's Autopilot and full self-driving just got a whole lot smarter. We're talking about a vision-first AI running right inside the car. Today I'm going to show you exactly how your Tesla learns, predicts, and plans its every move. Live on the road. Here's the plan. We'll break down how Tesla's computer vision works, how it thinks for itself using Edge AI on the hardware 3 and 4 chips, and finally, how its trajectory planning makes your drive smoother and safer than ever before. This is the deep dive you've been waiting for. First up, the most controversial part. Vision only. No LiDAR, no radar on new models. Just sight. Tesla uses 8 cameras plus powerful neural networks to estimate depth and motion. It's essentially teaching the car to see the world like a human does, creating a 3D understanding of its surroundings from 2D images alone. This approach is bold, but it's central to their entire strategy. So the car can see, but how does it think? It all happens on board, with Edge AI. This means your Tesla makes decisions in milliseconds, right there on its internal computer. When it needs to brake, change lanes, or merge into traffic, there's no delay waiting for a signal from the cloud. The processing is immediate, which is absolutely critical for real-time driving. This leads us to one of the coolest concepts, the occupancy network. The car doesn't just see pixels, it turns them into a detailed 3D voxel map of the world. It understands which spaces are free to drive in, and which are occupied by curbs, cones, pedestrians, or parked cars. This occupancy map is the foundation the planner uses to figure out where it can and cannot go. It's like a digital force field of awareness around the car. And now for the magic that ties it all together: end-to-end learning. Instead of relying on thousands of handwritten rules, Tesla's newer models learn directly from video footage. The system takes in video clips from the cameras and outputs steering, acceleration, and braking commands. This video-to-control approach results in driving that feels more natural, more human-like, and a lot less jerky. With that understanding of the world, the planner gets to work. Its job is to predict, choose, and act. It predicts what other drivers, cyclists, and pedestrians might do next. Then it evaluates dozens, sometimes hundreds, of possible trajectories for your car, simulating what would happen in each scenario. Finally, it commits to the one that is the safest, smoothest, and most efficient. It's a constant game of high-speed chess. To make this possible, the system relies on sensor fusion. The car isn't just looking through one eye, it's merging feeds from multiple cameras. These overlapping fields of view create redundancy. So if one camera is blocked, another can still see. On some older builds that still have it, radar helps provide a stable distance estimate, especially in heavy rain or road spray, giving the system an extra layer of confidence. You can actually feel the progress. Since late 2023 and into 2025, the updates have brought noticeable gains. Unprotected left turns are cleaner and more confident. The car signals its intentions earlier. There are fewer late brakes and sudden decelerations. It all adds up to a ride that feels more comfortable and less stressful for everyone inside. The system is maturing. Of course, driving on a highway is a completely different game than navigating a busy city. Highways are structured, with clear lanes and predictable traffic flow. City streets are pure chaos. The AI stack has to adapt on the fly, dealing with pedestrians stepping off curbs, cyclists weaving through traffic, random construction zones, and confusing, often contradictory signage. This is where the AI really has to prove its intelligence. So how does it get better at handling all this chaos? It learns from the fleet. Millions of Teslas on the road act as a massive data collection network. When a car encounters a tricky situation or a driver has to intervene, that data can be anonymously uploaded. Tesla's engineers use these hard cases to retrain the neural networks, and the improvements are then sent out to the entire fleet in an over-the-air software update. Your car literally gets smarter while you sleep. This requires a massive amount of computing power. Tesla's large-scale training infrastructure, including their Dojo supercomputer, crunches petabytes of video data. The key is that they are training the AI on raw video, not on simplified, hand-labeled data. This lets the system learn the subtle nuances of driving that are impossible to code by hand. More data equals better driving instincts. Now, you might be thinking, what about maps? Tesla's approach is map-light, meaning vision leads the way. Yes, maps provide helpful hints for things like speed limits, lane configurations, and upcoming turns. But the real source of truth is what the cameras see in real time. If a map is out of date and a road has changed, the vision system overrides it. It drives what it sees, not what the map tells it to see. But what happens when the system isn't sure? This is where safety layers come in. If the AI's confidence drops for any reason, maybe the lane lines are faded or the weather gets bad, it has built-in fallback maneuvers. It will proactively slow down, increase its following distance, or if necessary, alert you and ask you to take over. Multiple redundant checks are in place to prevent a single point of failure from causing a problem. And this brings us to the most important component of the entire system. You, the driver. Autopilot and full self-driving are Level 2 driver assist features. You must stay alert with your hands on or near the wheel, ready to take over at any moment. It's the combination of smart software and attentive human supervision that creates safe miles. You are always in charge. The real world is hard, and the AI is constantly learning to deal with the long tail of edge cases. Driving at night, in heavy rain, or through confusing work zones presents a huge challenge. Every weird scenario, every strangely placed cone, every unexpected event becomes a learning opportunity for the network. Progress isn't one giant leap. It's the sum of thousands of tiny wins against these complex situations. A big focus of recent updates has been on comfort tuning. It's not just about getting from A to B. It's about making the journey feel good. This means smooth, gentle acceleration, signaling intentions early so other drivers understand, and taking corners with a natural, comfortable line. The goal is to build trust, so that passengers feel as relaxed with the AI driving as they would with a skilled human driver. So, where does the system help the most right now? The biggest benefits today are on long highway commutes and in dense, stop-and-go traffic. Features like lane keeping, adaptive cruise control, and automatic lane changes take a massive load off the driver, reducing fatigue and stress during the most monotonous parts of driving. It turns a frustrating commute into productive or relaxing time. This highlights one of the most unique aspects of owning a Tesla: the value and ROI of software. With traditional cars, the car you buy is the car you own forever. With over-the-air updates, your car is constantly improving. It can gain new features, become safer, and drive better without you ever having to visit a dealership or buy a new model. It's software ROI that compounds over time. So here's my question for you. Would you trust an AI to handle your daily commute? What part of this technology excites you the most, and what part makes you nervous? Let me know your thoughts in the comments below. I read every single one. And if you want more deep dives into Tesla AI and full self-driving, make sure to subscribe and hit that notification bell. Thanks for watching.